Hi everyone. Today we are going to discuss about another sorting technique by using distribution counting. So this sorting technique again uses input enhancement technique just like when comparison counting. So in my previous video, I explained about sorting by comparison counting. That and as well as this distribution counting sorting both uses this input enhancement. What do you mean by input enhancement? See, given for the sorting, given one array to be sorted, that is only the given input. But from that array, what we are doing before solving the problem, so we are generating or we are getting or we are acquiring some additional information, external information about the given problem. With that additional information, we can solve the problem or we can sort easily in a faster way. So that's what the input enhancement. Again, this input enhancement is a type of space and time trade-off. Since we are generating the extra information, we have to use, in order to store that extra information, we have to use some extra space. Okay, that means we are ready to pay extra for space, but we are not ready to compromise with the time. That means here we are achieving the time efficient algorithm at the cost of extra memory space. Hence it uses a space and time trade-off. Now let us take this simple example. This is the given array of elements to be sorted. Okay, this element we have to sort it. Again, this distribution counting sorting technique we are using, especially when we need to sort the elements which are some limited range of numbers. That means the element to be sorted should be in between some ranges. Okay, so now here, which are the range with the numbers here, which is the maximum number among these numbers, which is the maximum 11, 9, 12. Okay, these are among this, which is maximum 12. So I will say here maximum is equal to 12. And here among these 5, which is minimum is 9. So that means here numbers are there in the range between 9 to 12. Okay. Now what I will do, this is only what the given data, given input. Now we need to generate the extra information. Already we generate one. We find out which is maximum and which is minimum. Also will say upper bound, lower bound. Okay. So now what I will do, now I will generate one array which will gives which element is how many number of time it occurs. That means, see, minimum number 9. So which are the numbers in between this range 9 to 12, 9, 10, 11, 12. There are 4 numbers comes in this range 9 to 12. So now 9 occurs how many times, 10 occurs how many times, 11 occurs how many times, 12 occurs how many times. That frequency of occurrences we need to find out. That frequency of occurrences I am going to store in one array called D. Now what is the size of this array D? That is the next question. Now this is the D array. What is the size of this one? So the size of this array is nothing but the maximum minus minimum plus 1. This is nothing but the size of array D. Size of array D is what? Maximum minus minimum plus 1. That is the size of the array. Now in this case, which is the maximum? Maximum is 12, minimum is 9, 12 minus 9, 3, 3 plus 1, 4. That means the total size of the array is D is 4. So there are 4 elements are there. Okay, now as usual, I will take the index from 0, 0, 1, 2, 3. See, if you observe, this is the array gives us the information about which number occurs how many times. That number ranges are what? 9 to 12. So that means this is gives a count of 9, this is gives a count of 10, this is gives 11, 12. Okay, 12. So that means 9 occurs how many times, 10 occurs how many times, 12 occurs how many times. This is the give. Okay, this 9, 10, 11, 12 I have done just for you to understand. So array index 0, 1, 2, 3 only. Okay, now check how many times 9 occurs in this one. 1, 2, 2 times. So count of this 9 is 2. Now that means 9 occurs twice. 9. Next number is what in the 10. 10 occurs how many times? No 10 here, so 0. 11 next 10, 11. 11 occurs how many times? 2. 13 next 12. 12 occurs how many times? 1. So totally see 2 occurrence of 9, 2 2 occurrence of 11, 1 occurrence of 10, that is 4. 4, 2 plus 2 plus 1, 5. 5 elements are there. Simple. This array gives us the information about what? How many elements are occurs, how many times. That means frequency of occurrences it will gives. That's it. Okay? In the range minimum, maximum to minimum or minimum to maximum. This is what the extra information what we have generated. Now, but here just I found how many elements are occurred, how many number of times. Now we need to find out the distribution values. Distribution values. The distribution values means these elements have to distribute in a sorted array from where to where. Okay, for that distribution, this distribution array, now I am going to write by using accumulation. Accumulation. Okay, that means what? See, first item I written as it is, this 2 as it is written 2. Next what I did, this one, this element I need to write by adding its and its previous. This element is what? 0. Its previous is what? 2. 0 plus 2 is what? 2. So this is my 2. Next I need to find this one. Again, this element is nothing but this element with previous element. This element in position 2, what is there? 2. Previous element is 2. 2 plus 2 was 4. Similarly, this element is nothing but it's this element, previous element is 4 plus this element is 1. So 4 plus 1, 5. This is my distribution value or accumulated values. Okay. So now with this extra information, now we can able to write the sorted array very easily. See, now sorted array, the size of the sorted array is always the same as what? The given array. So given array is of 5 size. So 0, 1, 2, 3, 4. Now what I have to do? See, now I have to find. We need to come from the last element. Okay. Now listen. Travel from the last element. Last element is what? 9. What we need to do is, we need to find this formula. Always need to check what? Element minus minimum. Minus minimum. Okay. Which is the element? Last element is what? 9. 9 minus minimum element. What? 9 minus 9? 0. This is the value it gives from where I need to distribute. This is give the position in the sorted array. Now 9 element, see here, observe these two, 9. Okay, element is 9 minus minimum 9. 9 minus 9, 0. In 0, what is there? 2. Since we have started the position 0, what I will do? That minus 1. 2 minus 1, 1. So in 1 I will write what? 9. Now this element is done. Now come back to this element. Next this one. Now again, element minus minimum. Element is what? 11 minus minimum. 11 minus 9, 2. So in position 2, what value is there? 4. You do minus 1. 4 minus 1, 3. In 3 position you write 11. Next this number is done. Next this element. Now this element again, element minus minimum. Element is what? 12 minus 9. 12 minus 9 how much? 3. So in position 3, what is the value? 5. Minus 1. Minus 1 in 4. In 4, you place this 12. This element is done. Next 9. Next this element. See, I am coming from this end. Okay, 9. Again 9 element minus minimum. Minimum is 9. 9 minus 9, 0. In 0th position, see, whenever I am placing here, I have to decrement this. See, now I decremented this one. This becomes 1. This becomes 4. This becomes 3. Now this becomes 2 as it is. Now, 1. 9 minus 9, 0. In position 0, 1 is there. 1 minus 1, 0. In 1, I put this one. Done. So this I decremented to 0 now. Next, 11. 11, element is 11. Minimum is 9. 11 minus 9 is 2. Position 2, what I am having? 3. That means in position 3, in previous position, 3 minus 1, 2. In position 2, I kept here. So this is decrement. That's it. Now, this is my what? Sorted array. This is my solution. This is how this distribution counting sorts the given array. Okay. This is the extra information we have generated. So, okay. Now, let us see how to calculate this frequency of occurrences and this one, and how to place the elements from the input array to the sorted array, output array. Okay. See, these are the 3 extra memory space I am using. Okay, to store this additional. Now let us see how to do this one.
Start.
So to do this, we are following 4 steps. First step, just finding the maximum and minimum in the given set of elements to be sorted. So then second one, we need to find the frequency of occurrences of the each elements of the given array. Third one is distribution value we need to find out. Fourth one, placing the input element in the sorted array using this distribution value. Okay, now let us take first one is done. Okay, the first one is very simple. We'll take one. Second one, how to generate this distribution value. For that, what we do now, what is size of this distribution? Whatever the problem, not for this problem, whatever the problem, whatever the max size of the distribution, size of the frequency of occurrences of this array is maximum minus minimum plus 1. Okay, maximum minus minimum plus 1. Okay, this is what the formula. Now, here, maximum is 12, 12 minus 9, 3, 3 plus 1, 4. This is what the, okay. So, this is nothing but now I have to write, so this array. Initially, what I will do, initially this 4 array, I'll make it as, so this is my B. Initially, I'll make all the elements are 0. This is the sum. Initially, I made 0. Next, now you check for each element. Okay, now you check for each element. Now, I am taking this as the ith element. Okay, this is my first element. Now, again, this is the array to be sorted. In this one, this is the maximum element, this is the minimum. 12 is the maximum among the given elements, 9 is the minimum. Now, I rewrite this one. Now, I need to find the frequency of our occurrences of each element. Okay, now for that, what I will take? I will take the first element. That means this is my ith element. I took this one. Now what I will do? Always that again the same formula. See, always I will do what? Element minus minimum. Okay. Now element is what? Ith element is what? 11. Minimum is what? 9. 11 minus 9 is what? 2. In 2 you increment by 1. Okay. See. In position 2, see, element minus minimum, whichever the position you got, that position is just increment. Initially, what I will do, initially it is what? 0, 0, 0, 0 initially. Now what I will do, this is element is 11, minus minimum is 9, 11 minus 9, 2. In position 2, I incremented, this becomes 1, remaining element as it is. Next, what I will do, next again I will rewrite. So 11, 9, 12, 11, 9. Next, I will consider the next element. Okay, next element. Now, this is my now I. Now, again, element is what? 9. Minimum is 9. 9 minus 9, 0. Now, 0th position you increment. 0th position right now it is 0. Now, increment this one. Now, this becomes 1. Remaining element as it is. Okay. So, next, again, I will rewrite the elements for you people. Now again I am taking the same next element. This is my next ith element. Now again element minus minimum 9. 12 minus 9 3. In position 3 I am incremented. Position 3 right now is 1 0. That I increment by 1. Remaining element I write as it is. So next 11 9 12 11 9. So next I will consider the next element. This is then my next element. This is my ith element. So that is 11 minus minimum element. 11 minus 9 is 2. In position 2 I am incrementing. Position 2 I am incrementing. This is right now it is 1. This I am incrementing. Remaining element as it is. So next I will take the next element. Next element in my list is 9. So that is the last element in this example. This is my ith. So now again element minus minimum. 9 minus 9, 0. In 0th position, I am incrementing. In 0th position, right now it is 1. That I am incrementing. 2, 0, 2, 1. This is my final distribution frequency of occurrence. This is what we got. That means 9 occurs 2 times, 10 occurs 0 times, 11 occurs 2 times, 12 occurs 1 time. This is what the frequency of occurrence of each element from this range to this one, 9 to 12. This is what we find. Now the second step is over. We find the frequency of occurrences. This is second step is over now. Okay, second step is over. Okay, this is what second step. Okay, let us, this is my first step. This is my second step. Now third step. I need to find the distribution value. So what I will do is, same I will rewrite this one only, D. Okay, this is 0, 1, 2, 3 index, D. First number I told will copy as it is. That means this is 2 only. Now this element I need to write. This element is nothing but this element. Okay, 0, 1, 2, 3 positions. Okay, this element is what right now 0. 0 is what? D to the D of 1. D of 1 plus its previous element is what? D of 0. Right now D of 1 is what? 0. D of 0 is what? 2. 0, 1, 0 plus 2 is what? 2. The 2 I am storing here. Next, this element. Again, this element is nothing but what? Its current present element D of 2. This D of 2 is 2 plus its previous, that is D of 1. D of 2 is right now is what? 2. D of 1 is what? Right now D of 1 is 2. 2 plus 2, 4. So this is my 4. So now this element, this is nothing but its element D of 3 plus its previous is nothing but D of 2. So that is D of 2, the D of 3. Right now D of 3 is 1. Its previous D of 2 is 4. 4 plus 1, 5. So this is my distribution value. This is also third element also we found. Okay. Third step is also done. Next we need to find fourth one. Now we need to place the given array elements to be sorted in the final sorted array we need to find. So for that, now what I will do, so now we go to the fourth step. So this is the given array of the elements to be sorted. This is what the distribution value we find out, and this is the sorted final array. That's the output array. Now I need to place the elements of the given array into the sorted array using these distribution values. Okay. For that we travel from the last element of the given array. So I will go for the last element. This is my last element. Now again. So now this element I need to store in which position of this array? In position 0, 1, 2, 3, 4. Which position? For that I need to find the first position. That J, that means here to which position? J. So that J position I will get from the formula element minus minimum. Okay, element minus minimum. Here which is the element? 9. 9 is the element. Which is the minimum? 9. 9 minus 9, 0. So now get the value stored in the position 0. What is this value stored in position 0? 2. You do minus 1 because we started the index from 0. If you started from 1, you use the same value. Now, since we started from 0, we are taking minus 1, whatever value here. Now, see, again, I'm explaining again. Last element minus minimum. Element minus minimum, same formula again. Element minus minimum, 9 minus 9, 0. In 0 position, what is the value I'm having? 2. Sum from 2 position, minus 1. In that position, you write this value, that is 9. So, write 9 here. Since out of 2 9s, I turn 1 9. Now I have to decrement this one. Now this becomes 1. Remaining becomes 1, 2, 4, 5 as it is. Okay. So next I need to take the next element. So for that again I'll redraw. So 11, 9, 12, 11, 9. Okay. So now as of now I'm having what? 0. Sorry, for you purpose 0. So 0, 9, 0, 0, 0. This 9 just to make it to visible clearly, I'm writing in another color. Okay, now next this element over. See, I'm moving from the last. Okay, this element over. Next, this element I'm taking. So this is my next element. Now again, element minus minimum. Element is what? 11. Minimum is what? 9. 11 minus 2, how much? 11 minus 9, 2. That means in position 2, what is the value I'm having written? 4. Minus 1. That means in position 3, you write what? 11. This is 11. Okay, remaining element as it is, I'm writing. Okay, remaining element as it is, right? 0, 0, 0, I'm writing. Okay, now since I have written from the position what? 4. So one element I have to reduce. So this becomes now 3. remaining element as it is. Now this is my current distribution values. Okay, now I'll read on again. Okay, now next element in the list is what? From this direction, next element is what? 12. Now again same thing, 12 element minus minimum. Minimum is 9. 12 minus 9, 3. In position 3, what value I'm having? 5. In position 5 minus 1. 5 minus 1 is 4. In position 4, you write this element 12. That means position 4 is this 12. Remaining elements I am writing as it is. Okay. So next. So which is next now? Since I have written 12 1, so you decrement this one, 5 becomes 4. So this is my current distribution values. Okay, next again. After 12, which is next element from this direction, this is the element 9. So again, element minus minimum. What? 9 minus 9 is 0. In 0 position, what value I'm having? 1. So minus 1. That means 1 minus 1, 0. In 0, I'm writing this element 9. So this is 9 remaining elements as it is I'm writing. Okay. Next, since I written one element, so this will be decremented, becomes 0, 2, 3, 4. This is my current distribution values. Now again, the last element in my list is this one, 11. Now again, element minus minimum, 11 minus 9, 2. In position 2, what I'm having? In position 2, I'm having 3. So 3 minus 1, 2 in previous position. In position 2, I'm writing this element 11. So this is my 11. Remaining element I'm writing as it is. And this is my final sorted array. This is my output. Okay, so now since I have written what? 11, so this I have to decrement. So this becomes 2, 0, 2, 2, 4. This is my distribution value. That's it. We covered all the elements. Thus, we got the sorted array. This is how our distribution counting sorts the given array. Okay, hope you people understood. Now, I will convert the same what we did in pictorially. Same thing now let me convert into the form of algorithm. Now, what is the first thing we did? For the given array, first, second thing what we did? We found the frequency of occurrences of each element in the range from this to this. This is what we did in the first. But before finding this, we initialize this array into what? 0. For that, now I'll write. So for now, what is the size of this array? Size of this array is what? Maximum minus minimum plus 1. So that means here, see, it is the D array ranging from what? 0 to what? 3. What in this case, 3 is what? Difference, maximum minus minimum. 12 minus 9, 3. Suppose, assume maximum is 13. Maximum is 13. Minimum is 8. Maximum is 13. Minimum is 8. Now, how many numbers will come in this range? 8, 9, 10, 11, 12, 13. 6 numbers will come. So range is what? 6, 6. Okay, 13 minus 8, 5. 5 plus 1, 6. Okay, 6 is the size. Okay, so always it will be done minus. So what I will do? So now for I is equal to, I started from 0. 0 to what? 0 to max minus min. Okay, so 0 to max minus min. You do this what? D of I need to make 0. That's it, end for. Okay, just for you people, those who are not understood, simply. Okay, for D, so 0, 1, 2, 3. D I equal to 0, max minus min. Max is 9, 12, 12 minus 9, 3. So this is 3. 0 less than or equal to 3. True comes inside. D of 0 is equal to 0. Next, incremented. I becomes 1. 1 less than or equal to 3. True comes inside. 0. Then I becomes 2, 0. I becomes 3, 0. When I becomes 4, 4 less than 3, false comes out. So this is how it fills 0. Okay. So hope understood this one. This for loop is just to initialize this array into 0. That's it. Okay. So now what I have to do? Now I need to calculate the frequency of occurrences. That means each element in this range, 9 occurs how many times? 10 occurs how many times? 11 occurs how many times? 12 occurs how many times? That I need to find out. For that, what is the formula we need to do? Is we find element minus minimum. See, in this one, I use this one, right? I took this as the first element. This was the first element. That means this is the first element. That means each position I. So that means this is my I here. This is ith element. Okay, ith element. That means I started from the what? First position and I moved to what? The last position. So I repeated. Okay. So what I will do? So for I is equal to 0, I start from 0th position to the last element I took. So 0 to n minus 1. What I did, now I need to use element minus minimum. So this one I have to increment whichever. Element 11. 11 minus minimum is what? 9. 11 minus 9, 2. 2. That is position 2 I have incremented to 1. So what I have to do? So now in the D, I did what? Element. Element is what? A of I. Ith element minus minimum. That one what I did? Same thing I incremented. That's it. Whatever is there that I incremented. End for. That's it. Now this for loop is to find the what? Frequency of occurrences of this one. Okay. So hope you people understood. See, A of I element minus minimum. So if it that one, so that I find out the incremented. Okay. For example, first one 11. Element is 11 minus min 2. 9. 11 minus 9 2. D of 2 is what? Right 0. Plus 1, 0 plus 1, 1 incremented. That one I stored in the same position. That means in this position I return 1. So similarly for other iterations. Okay. Now this is done. Now I need to find the distribution values. This one. This is what I did. See again, I will explain once again. This element, how I got? This element D of 1 plus its previous. This element is what? This element plus its previous. This element is what? This element, its previous element. That element, previous element. That element, that is ith position in its previous ith minus 1 position. Okay, that I did. So again for that I have to use what? For loop. So that for loop, again I am running from what? 0 to here only, upper limit, maximum to minimum. So I will write for I is equal to 0 to max minus min. What we did, simply I make D of I is equal to what? Its previous plus itself, D of I. Its elements and its previous element I added and stored the same thing. Okay, this is end for. Okay, this for loop is just to find out the distribution value. That is third step over. Three steps over. Now the last one, I need to write now code how we have copied the elements from this array into the final output array. Yes, using this distribution value. So what we did here, we traveled from the last element, okay, from the last position, okay, from this position, and I need to find out what is the position. So this is my ith position. This is I, this is I, this is I, this is I, this is I. Now I need to find the position for, yes, this position is different. So I'm taking one more variable J. Okay, J is the position for S. Okay, now here in, this is my J here. Here, this is my J here. Here, this is my J here. Here, my, this is my J. And now finally, this is my J. Okay, so now for that what I have to do, see, again same formula, element minus minimum. Okay, that part. Okay, now first I traveled from the last. So now here simple, see, now it is simply, it is what? Reversed. Now for, here from where I started, from last position. Last position is what? N minus 1. So for I is equal to N minus 1. Last position is N minus 1. Down to, see earlier in all the for loop 0, 2, that means 0, 1, 2, 3. But here we are coming down. Index 4, 3, 2, 1, 0, it is coming down. So I is running from N minus 1 down to 0. That means here, from I to here it is down to 0. I to last position is 0. Down to 0, what we have to do? Get the value of J. How to get the position value of the element minus minimum. Element is what? A of I minus minimum. This is what I got the position. Okay. So now what I have to do? Yes, in that position, in this position, previous. See, again, for example, this is the element minus minimum 9 minus 9 0. In 0th position, what I am having 2. In its previous position 1. In its previous position 1, I written 9. So S of D of J minus 1. In this position, what I have to place? A of I element I placed. 9 I placed in this position. After that, what we did? We decremented this 2 by 1. So D of J is updated by D of J minus 1. That's it. End for. Finally, we need to return the final output array, that is yes. So that's it, the algorithm. This is the complete algorithm for distribution counting. So this is how distribution counting sort the given array. Hope you people are understood. If you have any questions, please write it in the comments. Thank you. Thanks for watching.